Okay, we are up and running, so I'm going to take myself off of video and go on mute. But I will be on this call. I'll be watching and listening here. So
real good.
Thanks, Mike. All right, get about 2 minutes.
Yeah.
2 minutes to prime time, as they say. Now, typically, this is when the phone rings. So I think we'll turn that off. I wonder if I can do that.
Yeah, I've already given my kids a heads up. No busting in.
It's disconnected. It won't ring, I don't think. Maybe it will. Of course, that'll foobar the phone for everybody else. Probably. That's all right. Give it a clock. Countdown clock here. Good afternoon, folks. Looks like it's 2 o'clock. I'll give those that are having some technical difficulties, we'll go through some ground rules and begin introductions before we get into the session. I would like to welcome you to the New York State Forum Information Security Workgroup panel. We've assembled a STEAM panel of industry leaders with over 100 years of combined IT and security experience. Our format today for our panel is based on the panelists' experience as leaders in cybersecurity, and we'll focus primarily on opportunities to integrate better DevSecOps, container security, zero trust and zero trust as relating to application security. My name's Scott Rugler. I'm the CISO for the New York State Office of Temporary Disability Assistance, former co-chair of the New York State Forum Information Security Workgroup. I will be acting as your moderator. We will ask that you reserve your questions. We'll have a generous Q&A session at the end of our presentation today, or our panel presentation today. But please do take advantage of the Attendee Hub Q&A feature to ask your questions, and then we'll pass those along during that Q&A session. I do want to also thank the members of the forum staff, New York State Office of Information Technology Services for our, I believe, 28th annual cybersecurity conference. I think this is like my 18th, but we can't do it without our sponsors. And once we've completed our riveting session, please make sure to stop by the forum virtual booth listed on the Attendee Hub. And please do visit our sponsors. Again, we can't make this conference happen without those folks. So we do encourage you to do that. So without further ado, I'm going to introduce the panel. Again, our panel is made up of gentlemen, this time around anyway, gentlemen who have a variety of experience and bring great insights into cybersecurity, and I hope we have a great discussion. So our first panelist is Bill Malik. Bill is the VP of Infrastructure Strategies at Trend Micro. He's an ISACA certified systems auditor. Bill helps develop clients or helps clients achieve an effective information security posture spanning endpoints, networks, servers, cloud, IoT. This involves technology, policy, procedures, impacts, acquisition, development through deployment of operations and maintenance. During his 4-decade career, Bill has worked as an application programmer with John Hancock, as an OS developer, a tester, a planner with IBM, a research director at Gartner for the information security strategy services in the application integration middleware service, and served as CTO of Waveset, identity management vendor. I guess not recently, but it was acquired by Sun. He ran his own consulting business for information security, DR, identity management, enterprise solution architecture services for and provided services, for Motorola, AIG, Silver Lake Partners. Bill's has innumerable, I should say, publications and has spoken at many different events worldwide. Bill is an MIT grad, majoring in math. So we hope to have some Laplacian transform and Bernoulli sequence questions later on. He's a member of the Connecticut InfoGuard and ISACA. Bill, if you could say welcome.
Thanks. And that's all the time we have. Thank you. Glad to be here.
Thanks, Bill. Rusty Sides is the SE manager, U.S. public sector for Checkmarks. Rusty's over 23-year in software career in software development, sales engineering, team management, security consulting experience. During his tenure, Rusty has developed some of the largest some of the largest organizations in the world, ranging from finance to entertainment, Silicon Valley technology leaders in the private sector, and public sector organizations within DoD, civilian and intel communities implement solutions to secure software development lifecycles. Rusty is experienced as an ISSM, converting programs from, help me here, DIACAP to RFM, which achieve to achieve their ATOs. Rusty's background in application security is a wide range of programming language, software architecture designs, DevSecOps, public sector knowledge, and has been an asset to many speaking engagements as a government technology security conferences internationally. Rusty, welcome.
Thank you, Scott. Glad to be here.
And our third panelist is Sean. Sean, help me out again. Is it Ron?
Yep, it rhymes.
Yep, there we go. Business Development Manager, Digital Velocity Solutions for CDWG. And Sean has led the emerging technology innovations as a system integrator, developer, manufacturer for the past 20 plus years. Beginning with R&S as a network engineer, Sean has led multiple startup, advanced technology and engineering businesses ranging from wireless to mobile solutions, hardware design, manufacturing, agile software development teams, and most recently, a unique IoT practice Cisco and Intel consider to be the pioneering of IoT solution provider, noting that this team did IoT work before we called it IoT, before I could read, obviously, showing its mission to reinforcing the message that ever since we invented the wheel, technology has one primary objective: to improve our quality of life. Sean, sorry for butchering that, but welcome to the panel.
Thank you, sir. That was beautiful. Well done.
And last but not least, member of our panel here, Jesse Truck trucks, excuse me, is from Splunk, and Jesse carries probably the most unique job title of all our panelists, Minister of Magic. I'm not quite sure how you get to be the Minister of Magic. Maybe there's a test that you have to take, but Jesse, he's worked in IT and IT security for 20 plus years. And in that time, he has worked for Department of Energy at Oak Ridge, and at the D.E. Shaw Research Center, supporting HP clusters, supercomputers, multiple telecoms, and managed service providers. Jesse has also extensive experience in design and implementing risk mitigation and security programs, compliancing, auditing processes and systems, defensive security operations. He's developed multiple bespoke monitoring and automation systems. He has implemented a multitude of commercial monitoring, SIM, and automation systems. Jesse has worked with Splunk for about 6 years now and is also co-founder and principal of a small elementary school. He resides in Knoxville, where he adores his family, roasting coffee, raising poodles, and is an amateur radio enthusiast. I guess I think it's appropriate that you're N9MOM, Jesse, for those hams out in the audience. But welcome, and we appreciate all of you
Thank you for
coming
having
on
me.
board. So we have about an hour today, and as I mentioned in our focus here, sorry for jumping around, we are going to talk as much as we can, focusing on DevSecOps, but bringing all of your vast backgrounds into play. So, Bill, I think I'm going to start with you. DevSecOps has emerged as a way to integrate the management of security earlier and earlier in the development process, and how we, and probably more importantly, how it continues throughout that process. So I think about it following the PPT framework, right? People, process, technologies, as championed by Bruce Schneider in the 90s. My question to you to kick us off is, how do organizations integrate the SEC component without introducing too much delay?
Right. Well, thank you for pronouncing it correctly. Often the SEC is silent. What we see in people who are doing DevSecOps well is they introduce powerful automation technologies that are used up front as well as at the back end. So what I mean by that is, for instance, using a tool, say, to scan the static contents of a cloud segment of a container prior to deploying it, and then using the same scan technology when the object is in the production realm. The purpose here is to avoid slowdown, to avoid the process step where you have a security audit, which is done out of line and the results are then handed off later on, but rather to actually make good security just another example of a good development process. At its best, DevSecOps deploys needed, necessary, profitable, useful functionality rapidly into an eager consumer environment. At its worst, it's nothing more than the Ricky Bobby of IT. Just go faster, whatever it is, go faster. and we want to avoid that. We don't want to sacrifice necessary coverage. We don't want to sacrifice appropriate levels of due diligence. But on the other hand, seeing the way those things have been deployed historically, whether it's in waterfall or any other mechanism, it would introduce delay. Wait time has always been a significant problem. So to the extent those capabilities can be buried in the tools and rely heavily on automation, well, there you go. Just one case in point, and then I'll get off. In the last 3 years, among the major cloud providers, there have been exactly 2 instances where a cloud service provider introduced an error that led to exposure of private data. All the other breaches happened because someone somewhere along the line took what was once a completely secure cloud instance and altered a parameter which opened it up. I'm not throwing a rock at people for doing that. I'm just pointing out that when you have an environment that has over 500 parameters, getting them all right is a Herculean task. And so use a tool to help you out.
That's great. Thanks, Bill. So along those lines, Rusty, DevSecOps often emphasizes that developers should create code with security in mind, right? So security first, and aims to solve some of the issues with security that DevOps doesn't always address. So thinking about the adoption of DevSecOps or moving forward with it, if you will, what are some of the common obstacles that DevSecOps in your experience that companies or agencies have had with adoption of DevSecOps?
Sure. Yeah. So that is a common question, and it tends to be something that you really have to understand how development has matured over the past decade, and even more so now that the cloud has taken hold and cloud native technologies and development is embraced. There was a time where you would write a piece of software as a really large monolithic delivery, and you would give that particular software out, and it would be installed and used. And as software has matured, a lot of this process that's being done today is now composed of microservices. And with these microservices, they're talking to each other in ways that heavily use APIs. And suddenly the attack landscape is a lot different than what it used to be. But having said that, there's still quite a few legacy applications that are out there that are still highly vulnerable. So you can't forget the past. You have to still embrace the older way of development. So that's where automation and using different tools that are out there, such as static analysis tools, dynamic analysis, interactive analysis, software composition analysis, and even AppSec education types of products really help you to understand the landscape of where you are, where you sit, and how your particular software is vulnerable, what types of attack vectors exist on it. Obstacles to this often are the approach of either you've got vendor-defined DevOps, DevSecOps processes where the particular vendor you're talking to has got a subset of those tools that I just named. And so you get kind of a slighted version of what it is that you need to address, whether it be more of the running application or long before the application is ever deployed, scanning the source code, and ultimately setting up your own process of application security and making sure that you're covering all these. You have to take a look at what really applies to your particular understanding of your software landscape. So you really need to kind of get a good understanding of this is what we're composed of. This is where our particular vulnerabilities lie. We have source code. We have some source code that we manage, some source code that we don't manage, that we use from the open source community or third-party libraries. And you have to have the approach of understanding all of these different aspects and build as much of an automated process as possible. Developer adoption is often a challenge because there's always been a security group, a developer group, and an operations group. DevOps solved that communication problem where the developers and the operations were able to work together, and then security was kind of left out. So this DevSecOps approach that is now very popular and very much in demand is also bringing security to the table. And that's really what it is about communicating and automating those processes as much as possible. And there's a lot of this mentality of if it ain't broke, don't fix it. But the problem is what if it's broken, you're not even aware of it? So you're vulnerable and you think you're perfectly fine until you hit the headlines because of a breach. And over 80% of the breaches that are hitting the headlines today are all application security related. So what you'll find is if you get a really strong application security program and you use the right tools to detect and find those and actually take action to remediate the findings that they reveal to you, you can have a much more secure application security posture. And then your DevSecOps pipeline automates as much as possible to enable developers to have the capability of remediating this as part of their life cycle of development where they're addressing the bugs that they're already used to fixing, along with the security vulnerabilities, all within a single developer pipeline.
Thanks, Rusty. That's great. You know, keeping in that PPT process, you know, it seems to break the mold, if you will, the standard mold of, you know, here's the security group, and having the not just the integration of the systems, but the integration of the people too. So I think that is a great point. It seems to me though, and this is probably the old security hat going on, that, you know, we've always talked about a holistic approach, right? So the layered approach, if you will, is needed to direct really to address all the aspects of security for any kind of application development. Probably ramped or amplified even more so with the adoption or the reliance on cloud-based architectures, or building in the cloud-based building applications in the cloud. So thinking about, like, I believe it was last August that NIST published 800-207 regarding their zero trust. And I think it's very telling that DISA came out today, or excuse me, not DISA, but DOD came out today and said that they are migrating to a zero trust architecture. And I know there's others that have obviously championed it as well. You know, that never trust, always verify, but you know, that data focus, including Kevin Mandia this morning in his keynote. He was talking all about zero trust. And so I just want to think of that. And so, Jesse, I think I'm going to turn to you. So why is zero trust model critical in a distributed cloud native application? And maybe even more than a traditional environment, but I'm thinking that, you know, there's probably a lot of, it's critical in both environments.
Yeah. So historically, we talk about the, you know, sort of castles and moats, layered security, you know, layered defense, that kind of thing. And that is true. You still need layered defenses, right? Because there's like your known attacks, turn stuff off you don't need, all the usual stuff, right? But in a modern environment, you have your attack surface. So let me back up. We used to think about our attack surface as being just the internal part of the network, right? And so you protect the outside, and then everything is fine. Put your layers in the outside, everybody's safe inside. But now we know, because of insider threat and how host, you know, usually a lot of that gets bypassed, you know, with phishing attacks and all these sort of some of these more modern things, or you sideload through your vendors with supply chain attacks. They're sophisticated enough, and we're all aware of them enough, that the traditional approach was actually not the right way to do it anyway. Your attack surface has always been every single device and every user. But in a distributed cloud environment, they're not just behind your firewalls and you've got to do some extra protections. Those services are out there in the world. Now, obviously, with your GCPs and AWSs and things like in AWS, you can do your virtual private, you know, containers, and you can keep that sort of, it's almost like having your own little mini on-prem data center. But the reality is that if you're using microservices, those are exposed APIs to the world. So you have to make sure your connections are encrypted, your authentication and authorization happens at every single transaction, right? It's kind of like when Kerberos was invented, you know, way back when in the MIT days, you know, heyday. The whole idea was, oh, you authenticate, and then you've got this thing that says, I'm Jesse, I'm Jesse, I'm Jesse to everything, right? Well, now you don't just have a token, you have to keep proving it over and over again. Here's proof I'm Jesse, here's proof I'm Jesse, right? And then you expand this to be able to have an active response threat modeling. So what happens is you look at the contextual situation of whether or not Jesse should be authorized this time, to do this thing. So now you have, this is what zero trust, like zero trust at the basic level is always authenticate, right? That's actually not too hard to implement. There's lots of tools for that. But the real problem is, when should Jesse no longer be authorized to do certain things because the risk is higher? So it's a live risk approach on your threat modeling. You see, oh, Jesse's coming from a system that we see a possible malware outbreak for. He can no longer access the HR system, but he can go to the company intranet, things like that. And so I think that it's more so, especially since most of like a company intranet is cloud-based in a lot of cases. And in the last year and a half, many companies, even traditional companies and government agencies have discovered, hey, we can all work from home, which means now everybody's house is an attack surface, And so this is why we have to think about, if you go with a zero trust model from the beginning, shift left, do DevSecOps, build everything so authorization and authentication is done at every single layer and every single service, then it doesn't matter where Jesse's working from. Am I in the capital or if I'm at home? It doesn't matter.
That's awesome. That's perfect explanation. I can't add to that, but it hits home, especially, I think as we all sit at home doing our conference here, and I know there was a lot of head scratching on how and why, but adoption of that zero trust or planning for it, I think is definitely a subject that a lot of CISOs and CTOs have gone through in the past 18 months. It was a necessity for continuance of business, if nothing else. But so kind of keeping along on the line of zero trust. So Sean, thinking about zero trust architecture, where we treat every user, device, application workload as untrusted. Couple of thoughts that went through. So how do you create security around something like the master container, right? The big bucket, if you will, to ensure that the code from an application perspective, insecure code settings and those kinds of things are not being pushed into, say, a production container. That's kind of one thought on that.
Yeah, absolutely. And as you pointed out earlier, I kind of grew up in the command line interface of a Cisco router. So I associate a lot of stuff to that and the OSI model, of course. I always like to mock my software friends and my data center centric friends and say, it's good that you guys finally caught up to us in the networking world, right? Because segmentation is really one of the most fundamental keys to overall security, right? Not just from a penetration perspective, but from a performance perspective. If you go back about 3 years, one of the things that was, again, when I was building an IoT practice, one of the big things was there was a huge vulnerability. Somebody in China found a vulnerability and launched a bunch of denial of service attacks against video cameras, right? And that proliferated across the entire country. Right. Well, one of the good things for us was that if we designed it properly, those cameras could really only talk to one single network and nowhere else. Right. Containers kind of do that for us. The other thing they do for us in the application world is what I like to call the Cisco copy, start, run rule. Right. So you start up a Cisco router, it's got a startup configuration in it that goes into the running configuration. If you make some changes and you're doing something in the actual production configuration and it goes bad, you can copy, start, run to start from scratch. So you'll have that master image, right? Same thing with containers, they can do that. You have that master validated or whitelisted list of containers that you have where you've got all your rules set. If a penetration or some other incursion happens, you can just simply reset and replace, doing that copy, start, run process, so to speak, right? In that place, of course, now you take segmentation to another level, because now we can take segmentation and really apply it to the application itself and make sure that we are making containers safe for one application. If you've got like the web interface that the end users like me are going to go use, well, I don't need to have any access down the line of the application chain. I don't need the application backend. I don't need the database whatsoever. So excuse me, so you can segment the access and authority and multi-factor authentication, as Rusty was just talking about there, very well, very well. So if you can actually segment based off of function as well as access, then just like traditional OSI guy can design an IP network, you're going to be able to be more secure just by a proper design without all the additional tools, right? Then you validate that to it. And when you get that to that place, you can actually look at the host overall, right? Whether you're talking about different cloud providers or different hosts within a cloud provider, different virtual machines. You can move these containers around a number of different ways. There's built-in security in a number of different platforms, whether it's Docker, Kubernetes, or what have you. But being able to be flexible from a performance perspective in itself is a security measure, right? Making sure you've designed access from a networking perspective as well as an authentication and access management and event management perspective. The traditional IDS and IPS rules, the intrusion detection and prevention that we do, those are all key. But being able to be flexible and bounce around the different components of your application on the fly is really where containers, I think, take the application development to that modern stage where it can really be agile overall, not just from a development perspective, but from that security and performance perspective overall.
Thanks, Sean. And I think you stepped in my next question. So I was thinking about the big container, and then you really, I think you walked, what are the steps, so to speak, or what do you need to ensure that the hosts themselves, where the container reside, are hardened. And I think of configuration management, and I think it's a different. It's probably not necessarily a different skill set from a security standpoint, but definitely from a technology standpoint, where you have those containers, but the principles are the same. And correct me if I'm wrong here. That I want to make sure I'm locking down ports and protocols. And as Rusty indicated earlier, that and Jesse did as well, that we want to make sure that we're authenticating every time, and we have our encryption in place. Is there anything that we want to look at keeping minimum standards? I quite often we rely on NIST standards, maybe sometimes too much at the state and federal levels, as the minimum baseline. Any suggestions on maybe what the next steps up are?
Yeah, I mean, to narrow that down back into the host perspective, whether we're talking about cloud provider or the actual platform within the cloud provider, yeah, all your traditional rules apply. And, I believe in the KISS theory, right? So everything we did when we had a server sitting on our desk and we were developing an application, and then we had the client side on the other side of the desk, right? All those things still apply. We just have more flexibility into it now. You still want to make sure that you've got your proper virus scan software, your proper utilities, proper segmentation overall. But the flexibility of being able to say, okay, I've got a number of different hosts and a number of different cloud providers and any number of different virtual machine environments there in the runtime environment. And then, of course, containers on top of it. It's really compartmentalized in such a way that, again, I think that the best tool for security is performance and flexibility and agility during the development of the entire architecture.
Great, thank you. So Rusty, I'm gonna slide back to you for a second here. So obviously, a lot of state agencies within New York State, they're trying to truly adopt that kind of unified security posture that both you and Bill had talked about. So what, in your view, what role does the developers play, and what would you recommend to the agencies in the case of New York? Say, each agency is supported by a central IT shop, Office of Information Technology Services. So what would you recommend the agencies do to support developers in kind of moving towards DevSecOps and adopting some of the things like zero trust?
Sure. So one thing you have to kind of keep in mind is the different perspectives that a security team has on vulnerabilities versus what a development team has. So with a security team, sometimes it's heavily compliance driven. A lot of these standards like NIST and even if for DoD agencies, there's a lot of specific DoD types of standards with STIGs, et cetera. We can get caught up on that to where we're looking at everything from the perspective of a control and how can we just check the box and make sure that that particular control is addressed to get either an authority to operate on a network or just say, yes, we must be good because someone else smarter than me defined a standard and I'm sticking to that standard. With the developer approach, they have more of a problem solution way of looking at things. There's a problem, I need to go fix it. Here's the way I fixed it. And when you have that look, often it gets very functionality driven and the demands on the developer's time tends to be more quality focused versus security focused, unless they've been trained to be a secure developer, which is often the way that we're trying to push developers today. Whenever a developer is looking to get hired for a job, there's a distinction between a developer and a secure developer. And there's actually a lot of ways that we can really help the community with the universities and different programs that are out there really push and make sure that as we're teaching software developers and training them to enter the workforce, that we're teaching them in ways that they're becoming secure developers versus just coders. But kind of getting back to that different perspective, in order to really embrace developers into a program and make sure that they are very much a part of it with a security focus, have policies defined by the security team and let those policies get driven by automated processes with static analysis where you're scanning source code, scan early, scan often, and get those results available to the developers so that they can do ad hoc scans and see the differences. And there's different technologies, different approaches that really help streamline that. One concept is the concept of doing incremental scanning. So there are products that are out there where you can do a baseline scan that if it's a large code base could be done as part of a DevOps process using some type of orchestration tool such as Jenkins or many of the other orchestration tools that exist out there for this. And that gives you that nightly batch scan or weekly, or depending on what the cycle is for your DevOps process. But then developers can take those results and they can start loading them into the environment where they're used to working. So this would be IDE plugins integrated into their environment. If they're using issue trackers, having security issues integrated in with their bugs and their quality issues that they're already addressing. So as they go in, they can do incremental scans throughout the day, taking a bite out of that large problem a little bit at a time. And that way the security team and the development team is not overwhelmed by a high number of false positives or a number of issues that are coming. They're very focused on what it is that they're trying to solve. And it takes that problem solution approach that developers are looking at and marries it up with that security compliance, security policy approach that the security team is focused on. And that'll give you a very streamlined program.
Great, thanks, Rusty. I think there's probably some additional steps, but I did want to think about holistically if we're going to be adopting a program shifting from dev to DevSecOps or that kind of thing. So I think I want to go back to Bill just briefly here. As with probably almost any process that we do, whether it's an application or counting money or manufacturing process, obviously there's some metrics that we want to throw at it, Bill. And I was just wondering, what are some good, whether it's KPIs or just metrics to measure to know whether or not your DevSecOps transition or adoption has been successful? And are there really any kind of milestones that you want to look for as we look to adopt?
Well, yeah, there are a couple of things that really bear in on this. One, when it comes to indicators of performance, I think the most important thing to get in place before you make that shift is to get a sense of what it is you hope to get out of it. If it's, preserve quality and improve cycle time, well, then you fall back on what are your measures for quality and what are your baselines by which you determine cycle time. And the reason that can be tricky is if you go from, take the most extreme case, a waterfall environment, what you're looking at is different kinds of headcount spread across different time periods. And so you'd say, well, it took 9 months, but that was 4 teams comprised of up to 5 individuals in each team. Whereas if you go with, a more Scrum, Agile, DevSecOps environment, you have a lot of people in the room at the same time. So the question is, am I making equivalently effective use of resources? And do my metrics still make sense versus what it is for my target? So, the first thing I'd look at is, and I will not get on my soapbox about the capability maturity model, but just say that I really like efficient processes where there is reflection on why problems happen. So I look for indicators like, for instance, in a true DevSecOps environment, not only does the development team produce code that goes into the hands of the production operations environment, but they also produce other things. They produce test cases. When I was at IBM running our development process in Poughkeepsie, we had an observation, not a rule, just an observation that for every line of code that we shipped, we developed about 3 or 4 lines of test cases. So if the MVS operating system around 1980 consisted of 1.5 million lines of code, there was a 5 million line of code base of test cases against which you would be able to run a regression test across the whole thing. What I'd look for is that code based also available to the operations team? When a defect happens in production, can somebody in the production side take a look at the test cases that are relevant to that particular area where the defect was found and do a quick health check to see if in fact, something didn't happen that caused that functionality to screw up? And the flip side of the agreement there is, when we do figure out what caused the bug, then that goes back to development, not just for the fix, but also for the creation of an appropriate additional suite of test cases, so you can make sure that classes of that problem never happen again. So that's one of the things I look for. Do we share test data between dev and production? Another one has to do with quality metrics. Are they comprehensive? Does a bug discovered here have the same weight as a bug discovered there? And the reason that that's important is the further you get down the path in development, the more expensive it is to fix a bug. Again, going back to my IBM experience in the 80s, if we could fix a bug during, a design discussion, that was like a nickel, because, somebody said, hey, that's not going to work unless we do this, and you solve the problem. By the time you get into system test, where we have to create an environment very much like what we expect the production world is going to look like, and run that whole thing, the next bug will cost you about $10,000 in terms of machine time and setup and personnel and all of the management around it. But by the time that code gets into production, when a customer has to call IBM, again, this 1980 vintage numbers, with a report of a live bug, the cost to the IBM company was about $100,000.
Wow.
So the escalating cost of detecting defects militates for more energy spent up front. In fact, as a tester for the middle third of my IBM career, I viewed the development process as having 2 sides. There was the defect injection phase and the defect detection phase. And what you wanted to do was to keep the processes clean, and process maturity matters here, so that you don't inject so many defects. And then in the back end, catch them as early and inexpensively as possible. And when you fix them, don't only fix the problem, but make sure you've got the test case, or if there is no test phase, make sure you've got the test phase to categorically exclude the recurrence of defects of that kind. It's not enough to wake up on Tuesday and say, oh my God, the firewall's broken, let's fix the rules. And you fix it on Tuesday, and next Tuesday, it's broken again, right? You don't want to get good at fixing a recurring problem. You want to make sure it never happens again.
Yeah.
So
yeah.
that's what.
That's great. That's great insight. And before I forget, I was writing myself some notes here. Jesse, you had mentioned something when you were talking about the adoption of zero trust and cloud based, and I wasn't quite sure where you're going with it. So regarding zero trust, you were talking about shifting left in application development. Can you kind of expand on that a little bit?
Yeah, I guess I should have explained is it's basically jargon for exactly what Bill's talking about. So if you think about a development plan flow chart from left to right, right? From the viewers left to right, you start with, from again the viewer's viewpoint, you start with, this is what our idea is. Here's our steps. Here's our project plan. You go through time to finish product, and then you iterate, right? It's like an OODA loop. Shifting left means you take security from at the very end. Like I think it was Bill, you were talking about, you do a scan at the very end and then you go, oh, now we got to change things. That's over here. But if you shift left, you're going further and further to the very beginning. So basically it's the extreme shorthand of exactly what Bill's talking about. And actually so obviously it's sort of shift left in that process and timeline, but also it comes from the shift left bitwise operator for you binary geeks.
Thank you for that. And of course, my computer with all my questions just crashed, so we're going to wing it from here. So a little commercial here. For those folks that are out in the session, please do begin to submit your questions and answers. I think we're just about quarter of here, so we're running about 15 minutes left in the session. We do want to leave some time for questions. So if you could submit those via the Q&A portal, and Mike, our moderator extraordinaire from the forum, will definitely pass those along. Again, thinking about the containerization and obviously improving the speed to market for some of the stuff for an adoption, and I think it was Bill that had pointed out that, majority of the errors in cloud-based environments, majority of the breaches is what I think what you said, Bill, were based off of not the container to which that the cloud provider offers up or that people use, but it's the code behind. So where along the process do we have, and I'm going to open this up first to Bill, but then to everybody, where along the process do we find that malformed code or bad code, and we successfully identify it as a potential breach or a bug in the code? Because we're using a zero trust, does that give us more assurances? Or because we're using containerization, does that give us more assurances? Kind of expand on that if you could, Bill.
Well, zero trust is, from my perspective, a implementation architecture pattern. It's not a product; it's a characteristic of the environment, and it comes from the old notion of, those of you may recall, network access control in the late '90s and the Jericho Forum in the first decade of this millennium. What we're looking at there is to get away from the notion that there's a perimeter, and once you're in, you're allowed to do anything you can. At Georgia Tech, they have a really cool system where anybody can access the network. You have an ID, you provide a password, and at that point, NAC kicks in. And what it does is it takes a look at you and sees what your credentials are like. Then it takes a look at your device and checks the health of the device. Do you have relatively current updates? Do you have one of the approved antivirus, anti-malware products? Have you run a scan recently? Are your signatures updated, et cetera? We develop what used to be called a user behavior profile. And if that profile says, you're not who we think you are. Your device has been generating a lot of what looks like spam, or yeah, it seems to be you, but you've never logged in from a device in Belarus before. For these reasons, we're not going to give you all the privileges that you might otherwise want. Now, when it comes to the development side, what you need to think about there is, who is my user at this point? This piece of application, right? Who is it that's supposed to be using this code, and what characteristics do I assume? And what characteristics must I validate before I allow them to get into it? I think Rusty made a similar point. Um, a new bank teller can, handle deposits and allow for withdrawals up to a certain amount. But if I walk into the bank and, ask to withdraw $100,000, that teller cannot do that. They're going to go through additional, call them in IT security, risk-driven controls. So again, from the development perspective, what things do we want to double check? And here, this links back to the other question you asked, which is, what do we want from the user community? And the user community can help a significant amount simply by saying what kinds of users should be in this environment and what traits we expect them to display to allow them to proceed. I mean, everybody in IT knows that if you've got the ability to modify the firewall, you better be using some sort of multi-factor authentication. You better use a stronger than average password, so on. So it's those kinds of things that we look at, and don't expect the developer to be able to suss this out on their own. The point was made that they've got a lot on their plate, they're rushed, they've got things to do. But if in the specification you say we need to have a fairly high level of confidence this person is who they say they are, well, that's enough. That's enough to trigger the sec piece of DevSecOps to a further conversation. Well, what do you mean? What mechanisms do we have in this environment? What tests can I run? And that's how you build a slab of code that's a little more secure than average.
Sean, did you want to chime in on that too? Sorry.
I'm going to be very honest and say I don't think I can follow Bill on that one. I think he's good. I would just be trying to add value at this point. Why would I do that?
Rusty or Sean?
I can add a little bit more when we were talking about shift left. Often a question that tends to come out of that is what types of products that are out in the marketplace that can match up to that shift left concept. And in terms of application security, kind of the furthest right you've got is your production code that's already out there in the wild and ready to be exploited. So there's tools that can go out there and monitor in real time. Often they're called RASP, that will actually act very much like a web application firewall does, where it's trying to actively block and actively monitor what's going on in the wild. And as you start to shift left from there, you get into technologies such as DAST and IAST, which is dynamic application testing, where think of it more like a hacker in a box. And you take this product and you point it at a running website. It tries to hammer it and break it as much as it can and give you a report at the end and say, here's what I could break, here's what I couldn't. IAST is kind of a hybrid of DAST and SAST, which is the static analyzing, looking at the source code directly, where you instrument that running application and you get a lot more deeper introspection into how that particular application is built and works. So you can even get kind of a pseudocode look of what that code would look like, even if you don't have the source code available. And then kind of shifting left from there is your static analysis. Take the source code, white box test it, where you can actually see and predict based on how this code flows and how this particular code is interpreted, what is a possible way that I could exploit it and breach it. And then probably the furthest that you can shift left would be education of the application developer themselves. So that's where you tie in AppSec training, AppSec awareness. And if you can integrate all of these different technologies together, say you do a static analysis scan, it shows you there's vulnerabilities. As an example, there's a SQL injection that was found. And then have a real-time, just-in-time training where they can go straight from that SQL injection finding into awareness of, here's ways that you can write this. Here's remediation advice where you learn how to write your code in such a way that you're using prepared statements. You're using things that have already been stamped as this is a secure way of doing it. And then they don't repeat that mistake for future development.
We hope.
It tends to be kind of the furthest. Yeah, yes, exactly. We have been fighting SQL injection for decades now, and it's right there in the OWASP top 10. So maybe one day we'll finally squash that. But
Yeah, get it out of the top 10. That's right.
Exactly.
So, and I think that's a great idea. You know, in the general security awareness training, a lot of companies have, I don't want to say cut their teeth, but they've adopted similar practices. You know, when somebody gets caught in, you know, you set up a phishing test and somebody gets caught, and it immediately takes them to the training that, yeah, don't just click on random links in your email. And again, but keeping in mind that user, that's great. It works for the first time, and unfortunately people have short memories and they do it again 6 months later. But I like the idea, and I think that's great, even though we're really shifting to the left. Just as a reminder for the folks in the audience, again, please submit your question through the Q&A. We do have a couple that came in. So I think, Jesse, I'm gonna point to you first. Are there any recommended security frameworks or tools that are available that can help developers as they're writing code?
So I haven't actually done my own code writing in some time. I don't really tend to recommend specific tools, but I would talk about technology, like I guess frameworks and techniques. So in terms of frameworks for developing code, is what you should use is standard libraries that you've been vetted, that are either they're commercially been shown to be fairly reliable, or open source that have been reviewed and pretty much in general practice. Like everybody uses open source SSH. Why? Because it's good and everybody can see it and everybody does it, right? But I think in this discussion about shifting left and thinking about coding is really relevant here, because I think we have to remember the most important thing outside of the actual process of development itself is supply chain attacks are real. The unfortunate vendor, who I'm not going to pick on, earlier this year, really got caught out by that. But many vendors have been caught out by supply chain attacks in the past. But now we have this instant global news that can really shine a giant spotlight on things like this. And any one of us who are vendors who are writing software or internal software in an organization, an agency or a company, can have the same problem. And so ensure that whatever tools you are using, Rusty probably has some ideas, because you were talking about some of those specific types of tools, but keep all of your code in a repo and do checksums on it constantly, and keep those checksums stored somewhere in it, and be able to verify those all the time. Because if you're not doing that, then you can have software slip in that's changing your code and not even notice. It's extremely sophisticated attacks, but especially government agencies or private or commercial companies that are supplying government agencies and entities of software and services. These are the places where those attacks are going to be most commonly deployed. And so keep your development pipeline of your code secure and monitored. Don't just monitor the heck out of production, because it's not the only thing that has your crown jewels. You have to remember that the crown jewels being the data and security and service delivery of whatever it is your organization does, it's being protected by the software you run. So if that software, like all of us have talked about, if that software is not secure, then of course it's not going to work. You're not going to have your crown jewels secure. But if the systems that hold the development process and allow developers to operate on that code, to develop new things and to test things, is not secure from the very beginning, then all of it's insecure. But I think Rusty might have some specific maybe not, but specific actual tools in mind.
Yeah, I was just going to jump over and Rusty, the same question.
Mm-hmm. Well, in frameworks, I consider frameworks to be a double-edged sword, because they're great when they're written to be secure, and you can leverage them and know that a lot of the basics have already been taken care of. They're handling some of the common cross-site scripting types of mistakes that happen. It's all built into the framework. You use it in the way it was intended to be used, and you know you're safe from that particular type of attack. But the double-edged sword aspect of it is, as that framework gets more and more popular and more adopt this particular framework, it becomes a juicier target for the hackers, and they start to really dive in and try to find ways to exploit it. And then if they discover a way to breach it, they have a very wide attack surface, because there's a lot of people using that common code that they know will immediately be a 0-day hackable way of taking that particular system down. So then you look at the approach of, okay, I've got this framework that I have to really kind of make sure I'm not depending on it as being my only way of solving it. Just make sure that you build security in depth in the same way that you would do for all of the rest of your defense. You're not only using a framework that's secure, but you're checking that framework, and you're making sure that the supply chain of that framework is secure, and that the tools that you're using that are checking the rest of your code is also double checking that that framework stays secure as well.
Awesome. Thank you. So we got about 2 minutes left here, and I have a pile more questions. So Bill, I know you had indicated that you wanted to talk about the what we could consider the old code question. So how do you ensure that good hygiene practices for code development today might not be building on old code from 10, 15, 20 plus years ago, or from 5 companies back?
Well, the nice thing about code is that it doesn't rust or age. If the code was good 20 years ago, it's good today. When you want to apply better methodologies for secure code development, the question is, what do I have in terms of test cases? What do I have in terms of test scripts? What do I have in terms of test documentation that I can then work into the new framework? The problem usually isn't old code. The problem is missing or inaccurate documentation. And in the interest of time, I'll just stop there.
Thank you. Thank you. Unfortunately, I think that's probably all the time we have for questions there. And they were all great questions, and we could probably talk about this for another couple hours. But I did want to thank our panelists for joining today from all over the world. And I wanted to thank all our attendees for all their great questions, and the staff. I did want to remind folks that please make sure to stop by the New York State Forum virtual booth and all the corporate sponsors. And then also please do take a time to do the survey for our session. It should take less than 5 minutes, less than a minute if you're really quick. There was just a real quick question, and Mike, I'm not sure if you can grab those questions and save them, but I think we would like to run them by the guys and potentially run them offline. But again, thank you one and all for participating today. And we hope to see you June of next year, live and in person.
Thank you.
I learned a lot from you guys. Thank you very much.
Thanks, Scott. Thanks all.
Thanks, everybody.
Pleasure. Take care.
Thank you, everyone.